Hi, my name is Armand Maria. In this video, I'll be talking about some of the more technical details of Unclutter. More specifically, the architecture, some of the technologies that we have used, and the implementation of the backend. When we designed Unclutter, we used primarily the microservices architecture, but there's some pipes and filters concepts in there. The reason we chose this is because Unclutter consists of a few specific tasks that do not need to know about the implementation of the rest of the system. That allowed us to decouple our services completely and achieve an extremely high level of abstraction. We'll talk about this in a while. Unclutter consists of 5 primary services. Firstly, there's the front end, which Arno will demonstrate in the front end section. Then followed by the database, business logic, a processor, and a collection of services that we call the polars. We'll talk about each of these separately in a few moments. All of our services are implemented in Java and using the Spring Boot framework. Our inter-service communication is facilitated by RabbitMQ. There's multiple reasons for this. Firstly, RabbitMQ provides a messaging service between our applications using persistent queues. This enables us to store unprocessed messages should an unexpected system shutdown occur. The second reason is the compatibility between RabbitMQ and the Spring Boot framework. So let's start talking about the services. The main purpose of the front-end service is to host the MVC functionality, and secondly, to act as a middleman between the client browser and the backend services. We chose to use WebSockets to communicate between the client and the server because of the bidirectional communication that it offers. For more in-depth look into the front-end service, please take a look at Arno's video on the front-end demonstration if you have not done so already. Next up is the business logic service. The purpose of this service is to initiate various other tasks in the other services based on requests that come from the front end. For instance, when a user registers, the business logic server receives a message from the front end. It then requests the various required polars to start retrieving user information. It also asks the database to persist the new user. Speaking about the database, we are using MongoDB to store our user information. MongoDB is the most suitable database when high reads and writes are brought into play. The NoSQL document-based database management system suits our needs very well. Next up is the polars. Each of these services uses the API provided by a specific platform like Google or Facebook to retrieve information on authenticated users. Each of these services is a separate application, which means that the implementation of these services is whatever the developer chooses or what the API requires. It is important to note that these services are completely decoupled from the rest of the system. This means that if a new polar is developed, then that polar simply needs to be deployed on the server, and not a single line of code needs to be written for any of the other services, nor does anything need to be restarted. The system is pluggable at runtime. We also developed an API that allows the polars to interact with the rest of the system. This allows for simpler development in the future and allows third-party developers to develop new polars that can be deployed as modules on our server. The last service we need to talk about is the processor. This service has only one function, and that is to use the neural network contained in Stanford's core natural language processor to analyze text, identify parts of speech, and outputs the underlying topics in the given text. Let's talk about the pipeline between the business service right through to the database. So, suppose a user signs up with their Gmail and Facebook account. The business logic service will receive a message. It will then tell the Gmail polar and the Facebook polar to start retrieving items like Facebook posts and emails, for that specific user. The pollers then extract the raw text, so they strip away the HTML and images and send the raw text to the processor. The processor analyzes this text and returns a list of topics. The topics is sent to the database for persistence. The last significant feature of Unclutter is the priority queuing functionality that we have implemented. This means that we prioritize new emails from a newly registered user over the old emails of old users. This means when you sign up, we have a few topics ready to be displayed rapidly, even if we haven't processed your entire 10 gigabyte email inbox. I hope you enjoyed this in-depth discussion on the back-end implementation of Unclutter.